Well, good morning. My name is Eric Souhrada. I'm with the Office of Bridges and Structures. I'm a field engineer specialist. This is Dewight Jones. He's the District 5 Bridge Maintenance Specialist. We're out here on the bridge in Warren County, middle of October on Highway 65. The purpose of this video is to demonstrate epoxy injection procedures. We did some demonstrations throughout the summer with the epoxy injection, different districts, and we had a lot of requests to do more, and we decided to do a video so that folks can view this process in their office at their leisure. So today Dwight and I are going to go through the whole procedure. We're going to go through some of the equipment, and then we're actually going to go through the actual process, and we're going to videotape it all. So Dwight, if you'd want to talk some about the epoxy injection equipment. There's different equipment that you can use. He has particular equipment that he uses, but he wants to mention all the different varieties. So go ahead and talk about your different equipment that you use for epoxy injection.
Sure. We have a 14-foot enclosed trailer that we use.
And a 14-foot trailer will accommodate your air compressors, your barrels, and all the equipment, whereas if you go with the portable type, then you have to use the 5-gallon buckets. You can put it in the back of your pickup. It's less of an investment, but this is a lot easier to keep all your equipment together.
So some of the equipment that we utilize in our trailer here for the epoxy injection process, we have an air compressor generator combination unit. This is a Speed Air by Dayton. It's powered by a 13-horse Honda. We've had very good luck with this unit. That way we don't have to have a separate air compressor and a separate generator. The tanks, I believe these are 5 each, and it's a dual, so it's just 10.
Okay.
You don't need a lot.
Okay.
A lot of guys use a simple air compressor that you'd find in a garage anywhere. So you're running your PSI at anywhere from 18 to clear up to 50 if you're doing a beam injection on a hairline crack on an overheight bridge hit. We have a shop vac in the back there. Any shop vac will work. And then we have opted to put our epoxy in 55-gallon drums, and we use Graco chemical stick pumps to pump that out. Stainless steel. We go through so much volume, it's not handy for us to keep filling our machine with 5-gallon buckets. So
what's a ballpark value of the barrels for epoxy?
I think one kit, which would be 2 barrels of A and 1 barrel of B, runs about $7,500, but don't quote me on. And if you don't have a lot of bridges with a lot of delaminations, that one kit will run you, it could run you 3 or 4 bridges. So, right here we have our Lilly CD15 dispenser pump. We've had this unit for years and years, and it's done probably multi-million cycles. We've had it rebuilt once, and then every year we usually go through and put new O-rings and stuff like that in it. And then also the nice thing about Lilly, we can send this in and they can go completely through it at a very reasonable price. So
is that a local company?
It's based out of the suburbs of Chicago.
Chicago.
I think it's Aurora.
Okay.
I think.
What's a unit like that cost?
Years ago, that pump cost us $5,900. I'm sure it's a little more expensive now, but very reasonable and a very good product. We have chemical resistant gloves that we wear when we're dealing with the epoxy, and we use MEK for the cleaning of our equipment at the end of the day, and it's a pretty aggressive solvent, so you don't want to be using your bare hands, so we wear gloves. We also wear just simple latex or disposable vinyl gloves when we're doing the epoxy injection process, just to keep that stuff off your skin. Now, if you do get the stuff on your skin or on your clothes, you don't want to leave that stuff. If it saturates your clothing, you don't want to leave that stuff on for a long period of time. You want to get it off and then wash your arm, and then you're usually fine. But sometimes, I've never been exposed to it, but sometimes people can get sensitized, and it might be the certain brand of the epoxy that you're using, so you might have to change things around and find out what you're sensitized to and not sensitized to. And then also with the cleanup of the equipment, the MEK can be, a little hard on some people. Some people have used isopropyl alcohol, just simple alcohol to clean their stuff
Just
up.
pure alcohol.
Yep, it doesn't work as well for cleaning the equipment, but if you have somebody that's sensitized to
Right.
it, it's an option.
Okay. Now you're talking about the two-part epoxy. You said the A and the B. Can you expand on that a little bit, the different types?
Yes, the epoxy injection resin that we use, there's several vendors on the IM, the approved list of
Right, okay.
epoxy resins.
That's in the specification.
It's in the specifications. I personally use two different kinds, which is Crack Bond SLB 302 is what I have in the trailer right now. So it's a 2-to-1 ratio, so it's 2 parts A to 1 part B. Is what, and the pump dispenses all that. It's got metering pistons in there, so it does everything for you. And then also, once this this contraption here, we use paint airlines to plumb everything, and it's resistant to the epoxy resin. And then these are chemical resistant rubber hoses. And you'll want chemical resistant hoses, because if not, it'll just eat the inside of them out. Okay. And then you'll have issues. But this is just a homemade apparatus that we made, and then we hook on our Tempest mixer, which is our mixing dispenser. That's where everything gets mixed at. It's just a little black box. We'll show you a little bit later a close-up of that. And then we use 1/8 inch paint line that we plug into that, and then that goes into the ports in the epoxy injection.
So you use paint lines to get the epoxy from your barrels to the Lilly, and then you use chemical resistant hoses to disperse it into the mixer.
Correct.
Okay.
The shop vac is used to hook on to our rotary electric powered hammer drill, and we also use a vacuum bit. This one is made by Hilti. There's 3 brands that I know of that make these type of vacuum bits. This one is a Hilti. Dewight also makes one, and Bosch also makes one. Now this one the Hilti has 2 cutting blades. The Dewight and the Bosch only have 1 plane of a cutting blade. And I'm going to give everybody a little tip here. If you look at this blade closely, the carbides used to stick out past the diameter of the shaft of this bit. You need to take a grinder and you need to grind those off so that they are flush with the shaft.
And that's a 1/2 inch shaft.
This is a 1/2 inch, yep. And if you don't do that, your ports are not going to be tight, and you're going to have a lot of leaks around your injection ports.
Okay, that's a good
So
good
it's a
point.
very good tip. You need to take a grinder and just knock the bulk of that off until it's the same diameter as the shaft of your bit. And this one, you can see this one has two ports where the air sucks up through the internal part of that bit, and this is where your vacuum hose plugs into, and then it's an SDS plus. They're all SDS plus. So we have a spline shaft hammer. These are called Injector Ports, and I get these from Lilly. If you get a very, very shallow void, you can actually use a PVC cutter, and you can cut the bottom double hump off of that, and you're able to sometimes successfully inject a lot more shallow hole by doing that. All your other ports, you're going to have one of these that you're pumping on, and then you can fill or stop the epoxy coming out of the other injection holes. One way to do that is just use a cork and just drive that down in. When the epoxy fills up that hole, just drive a cork down and plug it, and that forces it to go to the next injection hole. Another thing that you can use is called a crimpet. It's just a little steel cylinder, and what you do on this, and you can see there's a rolled edge on one side. They won't fit very well if you don't do that, but anyway, you just slide that down over that, and then you can take a pair of pliers. By the way, you can't go buy this just anywhere. We homemade that. We welded claw hammers to the back of a set of snips. But so what you do on this is you pinch that crimpet shut, and that plugs it. It'll stop the epoxy from coming up through that hole and force it to the next injection hole.
Now, also with this, what Junior's talking about is you need this to pump the epoxy, because you slip the hose over this. You use this to pump it in. You can use these for your viewing ports and watch the epoxy come out here and then cap it like this. Or like he said, you can just put a cork in on the viewing ports, but this is what you need for pumping. And when you use the corks will be flush with the pavement. These will be sticking up. You can go out there with a shovel when you're done, or this thing, and cut these off flush, so they're not sticking up for the traffic.
This will stick up probably 1/8 of an inch, but I have never, since we've been using these for over 10 years, I've never had a tire get cut or anything like that. You want to push the crimpet down as far as you can.
Right.
The advantage of using the crimpets is you can cut these off right away, like that, and you're good to go. The disadvantage of using this or a cork is you can't come back to that port and pump on it.
Right.
I'll show you one other little product that we use that you can come back and pump on it.
Okay.
Now, one advantage, and this is my personal favorite technique to use, is we use what we call a cap-it. We get these through Lilly. They come in a bag of like 500 or 1,000. But the advantage of this is when you get a port that's filled all the way to the top, you can put this rubber cap-it on top and just push it down with your finger, or you can give it a little tap with this hammer, or this. Now the advantage of this is you're going to stop the resin from coming out of this port, force it to another. But if you want to come back to this port and pump on it again, all you got to do is pop it off. Now another advantage to this that I like is once you use these cap-its on all your ports, and then after your epoxy sets up in the stem, you can come by, and Eric's going to show you, you can just hit that off right there, ice pad, and it'll just pop it straight off, flush with the deck level.
That's true.
I like that aspect because I like to wait until the epoxy is completely set up.
Right. One
thing that everybody needs to be aware of is if you turn traffic loose before all that epoxy, that you're going to get some that spills out on the deck. You can get epoxy on cars and get tort claims and stuff
you're supposed
like that.
to sprinkle that sand.
But you still may get some
residual. Yeah.
Some residual.
What I like about that is if you use that method, you're going to cut this off flush and you won't have this little metal piece. And what I was thinking of more than vehicles is they have a lot of bicycles and motorcycles, and this might be a little more detrimental to the smaller tires. We want to talk a little bit about the sounding equipment. We have to identify the spalled areas and delaminate areas on the bridge that we want to epoxy inject. I wanted to mention that this is a 1958 pre-stressed beam bridge, and it had a 1984 PC overlay, and the delaminations on the bridge are between 10 and 50%, which is the range that they'll usually select for a candidate for epoxy injection. Once you've selected the bridge for epoxy injection, one of the first things you need to do is come out and clean off the bridge, and then you need to identify the areas you need to inject. And Junior's going to go through some of the equipment that he utilizes to mark out the delaminated areas.
So, one thing that I like to do first to quickly identify the delaminated and hollow areas is I'll just use a simple paint gun, and then I'll use a chain drag. And I've actually homemade this one because I'm getting older. My ears aren't as good as they used to be, and I've found that when I use 4 or 5 chains on my homemade chain drag, it really resonates, and you can almost feel it through this steel shaft. So this is probably 1/4 inch cold rolled steel. Just made a simple T-handle, and you can make this different lengths for your height, or you can make several of them. And then there's just 5 chains on this one. It's all homemade. And what I do, I'll quickly use this to identify a spot that's delaminated, and then I'll just make a quick paint mark. And then I'll go back later with a steel shaft claw hammer and then sound out my exact dimensions and everything of the delaminated area. Now there's different tools that you can use for the finding those delaminated areas. Some people like to use just a steel shaft rod, and they'll just walk along and find it. Some people like to use a rope connected to a piece of chain and then just slide it back and forth. There's rub blocks.
I've actually seen a rod like this. They kind of combine a rod and a chain, and they'll put the chain on the end and have it about that long, and they'll just swing that single chain, a heavier chain, back and forth to do the same thing. But the whole idea is to listen for that tone, and then you mark the center of it, and then you take the hammer and you go around and get the perimeter of it. That's the idea.
And I can show them that. The delaminated area and made a quick mark on it. I'll come back and I'll use a steel shaft claw hammer. And it's important to get a steel shaft all the way through because it resonates and you can actually kind of feel the vibration. I found that helps a lot. This is just a 16 S-wing, and then you're just gonna peck on it and find the delaminated area. And then what I use is just simple lumber crayon, and I'll mark that area out like that. And this isn't actually a delamination, we're just showing you this for purposes of that. And then once I get that marked out in crayon, I'll paint over it with paint, upside down marking paint, and then that shows me my void. And then when I paint my injection port holes, I want to stay 6 to 8 inches at least from the perimeter of that void. And then depending on the size of the void, we'll show you how to do all that later on.
Purposes of the demonstration, you've got your ports that you're pumping, and you got your viewing ports, and you normally try to pump up slope in the bridge if you can.
Yep.
So if the crown is up there, then you'd put your pumping ports here and your viewing ports over there. And try to pump that way.
Yes.
Yeah. And for those of you that are watching and paying attention, this is asphalt, and we're just doing demonstrations. We're going to do the concrete bridge deck later, but this is asphalt, and you don't inject asphalt.
Talking a little bit about it's kind of a safety aspect of this. Traffic control when you're doing this. We like to maintain one lane of traffic whenever we're doing anything out on the road. And what we're utilizing today is we're using portable traffic signal lights, and we have one lane closed down and one lane open to traffic, and they're just alternating. We use cones in the daylight. We're able to use cones. Then we set it up in the morning, we tear it down in the evening.
Right.
And we do that every single day. And you could also use flaggers if you wanted to. If you have a project that has stage construction with TBR, and you can get in there and do it, then you can do it under
Joint
that.
replacements, anything like that. The main concept is that you don't have to close the bridge down. You can leave it open to traffic. You can epoxy under traffic. And once you're done and you've actually put the sand over it, you can open it right up to traffic again as soon as you're done, as soon as you get traffic control down. So that's a real positive feature, not having to close down traffic. So we just wanted to demonstrate the traffic control.
And we mark out our perimeter of our delamination. What I like to do is I like to use upside down inverted marking paint, a different color, and I like to paint the perimeter with paint. Reason being, if we get rained out tomorrow and we're not able to get back for a couple weeks, these marks will still be here. And then the other reason I like to use a different colored paint than my spot paint is this mark right here, as you can see, is very close to the perimeter of this mark. So if we drilled that, it probably is not going to take. You need to be a little bit further out. So what I'll do is I'll mark the perimeter, and then I'll put a few spots where we're going to actually drill, put in our ports. And if anything, I want to be on the inside of that mark. Purposely, I'll put them about a foot in. The epoxy will flow to the very end of that.
Right.
So I like to keep them in. That way I get a good location where it's going to flow.
Okay.
And then I also like to jump over the crusher. And then I'll put at least 2 on each side just because this is a large one.
I see. So you're actually identifying the major crack. I got it. This is really hollow clear to there. It's kind of getting hard. Yeah, there you go. Harder, yeah. Junior just mentioned another important aspect that when you push the epoxy into the deck, the epoxy is heavier than the water, so it pushes the water to the surface, which is another benefit of the epoxy injection, because that water is full of salt and de-icer, and that'll pump it out of the deck and get it away from your reinforcing bars. And another point I wanted to make as far as epoxy injection goes, we're dealing with a PC overlay here, which is primarily what started the epoxy injection research, but I've also been on decks, slabs, concrete continuous deck slabs, where we've epoxy injected the decks. We've been on hit beams, epoxy injected hit beams. There's a multitude of uses for the epoxy, so don't just think your investment is just for PC overlays.
The epoxy is the compressive and the bonding strength of epoxy is actually more than concrete. So it will actually bond to itself, concrete, whatever. You can pump the deck 2 to 3 times, and that epoxy will just keep bonding to itself in the concrete.
So the epoxies have gotten much better in the last 10 years.
Definitely.
For that use. So
Definitely.
It can be used for, I've even seen where they've used them for joint repairs, where they put in the fine aggregate, and for the surface they put the epoxy on the surface, and that worked very well too.
Yes.
So there's a multitude of uses for the epoxy, and I'm sure in the future there's going to be more. So I'm bringing this up so that if you have an investment that you want to make in epoxy injection, it's not just a singular unit. Some of the examples of what you can use the epoxy injection for are for I've seen them use curb repairs, rail repairs where the concrete's fallen off. They've epoxy injected it to hold it together. They've used it for joint repairs for the top seal. They've used them on concrete continuous beams to seal the deck. Of course, PC overlays, hit beams, very important on a hit pre-stressed beam. They pump in the epoxy to seal the pre-stressing strands to protect it from the salt and the icer. So there's a multitude of uses for epoxy injection, not just PC overlays. And I always want to stress that, because if you're going to invest the money, you want to use it for multiple uses and not just a singular use. They've actually tested what a spall is the surface of the deck is rubbleized, okay? And they've actually poured epoxy on that rubbleized surface of the deck, and it actually held it together. Now that's not something we've done research on, but just outside of the research, the guys have independently tested that, and that's worked well too. So one thing you want to be cautious about, and I just thought of it, you drill cores through your bridge deck to see the condition of the deck, and I thought it would be a good idea to put a board underneath and fill it up with epoxy. Don't do that. The heat hydration is tremendously hot. It starts to boil, and that's a bad idea. So I just thought of that, and I wanted to pass that on. Don't use it in large quantities. It doesn't react well. Okay, we wanted to make a few points about deck condition before we started actually drilling. We had a snow event here last weekend, or Sunday, and so we postponed this for a day to let the moisture evaporate. You get a heavy rain, moisture gets in the deck, into the cracks. You go to drill it, and the powder's gonna get pasty, and it's not gonna clean out, so you're not gonna get a good port for pumping your epoxy. So you don't want to do the epoxy injection after a heavy rain. You want to give the deck some time to dry off. And with that, we don't normally promote injecting in the middle of October. Temperatures today are going to get up in the 50s this afternoon. It's about 40 right now. It'll still flow, but it's not ideal conditions. But we wanted to mention about the moisture, and if you don't use this vacuum drill, if you just use a regular drill, you're gonna use a vacuum to suck the dust out of the hole instead of using the vacuum. You want to be careful with an air compressor if you're going to clean the deck off, because you don't want to blow the dust into the hole, because then again you're contaminating it and you're going to plug it up for the epoxy to flow. And I just wanted to make another point on this, if you'd want to zoom in on this. Junior mentioned grinding off these edges on the bit, because you can see when you put this port up there that there's going to be a little bit of friction on there. If you don't grind these off, these aren't going to fit snug, and you're going to get leakage.
One thing to reiterate on the deck condition, like Eric's saying, you don't want to do it with a lot of moisture, because if you have moisture in the deck, those ports in your vacuum bits right there will plug up every time you have moisture in the deck.
And there's ports in here, 2 couple of ports. Yeah, there's the ports.
will plug up.
Yep. So if you get moisture in your deck and the concrete pastes up on you, they're going to plug up these ports. So it's important to keep the holes clean and dry.
I'd say probably a general rule of thumb, 24 hours of dry.
Okay, 24 hours to dry. That's something to go on. It's good advice.
The other thing Eric was talking about is when you're drilling, you don't need to push hard on this hammer. This hammer here is big enough and heavy enough. It'll do the work for you. You don't actually want to push, because if you hit a rebar, a reinforcing bar, right, you'll snap these bits off, and they're pricey. You know, you're looking at $67 to $90 for these bits. So just let the drill do the work, and if you push too hard, you'll plug those ports up. So just let the drill do the work, and then you're going to actually hear a difference when you get into that first interface, that first delamination. And you may also, especially on this void here, you're probably going to see and feel this drill actually drop down when it hits that void. Yeah. And then I like to drill a little bit further, 4 to 5 inches every time that I drill a porthole, because a lot of times there'll be two interfaces, two delaminations at different levels. And you're going to fill that whole drill hole up with epoxy anyway, right, so it doesn't matter if you drill deep every time.
You're not going to compromise the reinforcing.
Nope.
So you go 4 to 5 inches from the deck surface almost on every hole.
Yep. Okay. So I'll go down. You can see this old bit's got marks on it up to here, and we drill ours every time that deep.
Would you ever put a tape mark on there or something, or mark it so you never went deeper than that?
Yeah, we've done that. If you guys are going to do drilling for epoxy injection of a pre-stressed concrete beam that's been hit by an overheight load, this hammer will get very heavy, and you have to space your ports a lot closer, like 4 inches, where here we're going 12 to 18, you know. But you got to do those crack injections on those pre-stressed concrete beams about every 4 inches. So I would recommend getting a lot smaller, lighter, maybe a little bit faster drill. And you want to space those a lot closer, like 4 inches is a good rule of thumb on those beam injections.
Yeah, and the pressure's a little bit higher, with the epoxy to push through them small cracks on a hit beam.
Yep.
So, okay.
Yep. We've
That's
gone
a good
up
point.
to 50 psi.
50 psi
on the. I don't like to, but sometimes you have to and you need to on a crack injection on a beam.
Okay.
Where we're running 18 to 30, 35 on the delamination injection on the bridge deck. When we're doing a larger delamination, this one's pretty good size, and you can really hear that it's really hollow. So you can space your portholes out quite a bit further, 12 to 18 inches, and get by with that. Now on your smaller, if this delamination was only this big, I'd probably put them closer together. So it's just basically size related.
Because the larger the delamination, the larger the cracks, and the easier the epoxy will flow, so you can push it farther. You get a smaller spalled area, you're going to have smaller cracks, and it's going to push harder, so it's just simpler to make the ports a little closer.
And one other thing, if I have a very, very small delamination like this big, I always like to drill 2 holes. Every single one, basically a viewing port and a pumping port.
Right.
And if you only drill one, you have no idea what's going on, and you're building a lot of pressure in there.
Right.
So if I always drill 2 holes on minimum.
He calls it jumping the crack, and you can see here, this is the major crack here. Well, he puts in a pumping port here and a pumping port here, and he jumps the crack. He puts one on the opposite sides of the crack. So he pumps it across the crack. Because the point that Junior was making is it doesn't always go across the crack, and you want to make sure it does, and that's your viewing point, so you always want to jump the cracks. We want to go back through kind of the system of how we do samples before we start, and then we're going to do some epoxy injections with different processes.
So we've got our hoses all hooked up, and we're going to put a sample for 2 reasons. First reason is by running a sample out, it will let us know that our ratios are correct, and it'll get hard. And then the other reason is it gives me a gel time of how long it takes for this stuff to set up and gel up. And we just run it into a cup with no moisture in it. You don't want any water in it. But anyway, we use empty coffee cans. So this one's got a little bit of sand and epoxy in it. So I'm going to just run a little bit in the bottom, let it get mixed up nice. And over time, probably in an hour on a day like today, it'll start kind of smoking, and you can touch the outside. It gets warm, you know, the chemical reaction starts taking place. So that's why we do that.
When we take down traffic control, we may want to give it some time to set up before we open it up then when it's cold like this.
Yes, and Eric brings up a good point. We take every precaution to sand any epoxy that's on the bridge deck, but if you know your gel time, you get done with your epoxy injection, you know that gel time, if it was 30 minutes, then you need to wait an additional 30 minutes before you tear the traffic control down and turn it loose to traffic, and then possibly they get epoxy on their tires, flips up onto the car windshield, the paint job, and this stuff is a very good product. If it gets on paint, it's going to stay on the paint. It's very difficult to get off. So our system, everybody's a little bit different, but we have a homemade valve that we came up with, and this lever turns it off and on. It's in the off position. We've got an on-off switch on our pump turned on. Air's hooked up, ready to go. So I'd like to just throw the valve and let some run out, so we know that it's starting to mix. You're going to have a little NDK come out at first, and that's okay. There's some air bubbles. You want all that stuff to work out before you start injecting into the deck. So this is a good measure to get rid of all that. So now I've pretty much got all the air bubbles out, and you can hear the machine cycle. And usually the bubbles occur, you know, in that cycle. So we're pretty good there. I'm just going to shut it off. And we're just going to leave this sit right here. And then I'm going to look at my watch.
11:20.
11:20. And then I'll remember that when I look over here periodically, this will start smoking a little bit. And then I know it's starting to do the chemical reaction. And then I'll keep visiting that. And then when it gets solid, it'll be hard. And then I know what my gel time is at the end of the day when I can turn it loose to traffic. So now what we're going to show you is we're going to show you some different methods of your viewing ports and your injection ports. So we've already got our delamination. We've already drilled it with our vacuum and hammer drill. We've got our port setting tool. I do want to use the double heads on this because it's deep and I don't have to worry about it. That's why I was hunting. I need to grab some.
But he had a bunch of the shallow ones in here, and he's going to go get the double-headed ones. You get a shallow spall where you're only drilling about that far, he puts in these shallower ones so you have more of a port. So that's what he's getting.
So as we're getting ready to start porting this delamination, there's a couple things that I always try to keep in mind. First thing is, this bridge is pretty flat, so I like to work from the downhill to the uphill side, and I like to push this stuff uphill. Then I know that it's getting all the way through the delamination. So this bridge is pretty flat, but every bridge has, well, most bridges have crown at the center line. So what I'm going to do is I'm going to start on the downhill side, and I'm going to work my way up that way and try to push this epoxy uphill. So I'm going to take my port setting tool, take a double hump injector port, put it in the drilled head. Simply just going to tap it down in until both those heads are all the way down in there. And if you see on this port set tool, we've beveled it just a little bit right here at the end, probably 1/8 of an inch, and that way it'll go down, but not down too far. So we've got our lead lines, we've got our Tempest mixer, and we've got our little 1/4-inch OD line, and we've got a quick coupler on the end. And then that's simply just going to pop onto that injector port stem, and then we're going to turn on the valve. I like to turn them on a little bit slow. And then another thing that I'll mention is on your dispensing pump, it's got a metering piston, and you can watch that, and you can also listen for it, the cycles, right? We'll turn it off just for a second. And then you gotta watch out, because when you put these in with epoxy in there, it might squirt out. And usually it'll actually go back down. You can see it's actually going back down. Pump off, cut it off. Come back down. So we'll go ahead, port this.
Then we're gonna wait till it comes out.
Yep. And I actually like to wait until there's a little bit of epoxy that fills up that hole right there.
Oh, it comes down.
Yep.
It'll come out and fill up the hole. Yep.
And then I'll
cut it off twice, level with the gun. Then it won't hold any salt, right?
Exactly. Okay. So we're going to show you a couple different ways that we can do this. I'll start out with the crimping. What do you think, Eric?
Yeah. Get the crimping one first.
Okay, so we're going to show you one way of capping off a viewing port. The downfall of doing this way is you can't come back and inject on this port. It's going to be sealed and you can't pump on it again. So like we showed you before, you take these little crimpets, is what they're called. We get those from Lilly. Slide that all the way down. And then you just take a pair of pliers and you squeeze that shut. I'm probably just going to leave this, but if you wanted to right now, you could go ahead and cut this off right above that crimpet, and then you don't have to do it later.
What happened here was he was demonstrating this collar, and he forgot to put a little more epoxy in the tube is all. He wanted to run some epoxy through the tube and fill up this hole and then clamp it down, but he was demonstrating how to use the clamp, and he forgot to do that. So that's all that is.
Which is no big deal, because when we pump, it's going to fill it up from the bottom side of this port, and I'll run some epoxy down in here, and it really doesn't matter. We can cut this off right here, and we're still good. But I like to fill up the little hole to the top surface of the deck. So I'll show you guys another little tool. This is for taking the quick coupler off. Simply, that goes over the line. So I would go like that, pop it off. Okay. Yep. So I'm just going to fill that stem up a little bit. Hold it down. I'm good. I'm going to go back on this port and pump some more on it. And I should start seeing it in other ports. Then we'll show you a different way to do this. We're gonna block this viewing port with a cork. Just gonna put it right in there. Watch out, it may splatter, and we're gonna tap that down where it'll plug it. If we want to drive it just a little bit deeper, we can set this on there. Pump it down in there to get a good seal. We've already got epoxy filling up that hole, so I'm not worried about that. And when I turn this back on, I want to watch this and see if that puddle gets bigger.
Yeah,
that tells me it's leaking. Not a big deal. What you can do is just drive that one clear down in and get another.
Put it right on top.
Right on top.
All right.
And if you can't get a cork to seal, you can grab an injector port.
Port.
Yep. And then also, pretty simple if it does set up in there. You can take, what we do is take an injector port when we get done at the end of the day. We'll put it in there after we wash it out. Then you got something to grab onto and pull it out. You can also take a drill bit and you can auger out that epoxy after it sets up too. So not a big deal. So we've got some more epoxy that came out of this one. This time we're going to use an injector port and we're going to use a cap. So we've got our port. We'll load it in our port set tool. We've got her shut off. Then we're going to drive that down in. I always try to tap it on the deck to get that epoxy out of there. And then we're going to use it to cap it. And I'm not going to make the mistake I made earlier. I'm going to turn it back on.
Down and let some come out.
I'm going to let some of that come up and out, fill that hole down there, and fill the stem with epoxy, and then I'm going to just simply put this on there. Doesn't take much to get these on. And then you can simply take this and push it down. So that one's sealed off, but the nice thing about this, we can actually pull this off and we can go to that port and pump on it. And another thing that I can mention, you can tell where your epoxy's at by sounding this. Yep. So this is solid. It was hollow before. That's hollow. So my epoxy is about right here. So you can actually tell by sounding where it's at. I like using the injector ports with a cap because then I have the option of going back and pumping on that port. And there's black and blue and there's no difference. Let my stem fill up with epoxy and fill the hole around it. And another thing that I can mention, if that was real milky color, that would tell me that there's some moisture and water in the deck.
So you let that milky stuff come out first before you cap.
Yes, and it'll eventually the milkiness will turn to a clear like the epoxy, and then you're good. And I've got it shut off and it's still just boiling out, and that's okay. It tells me we're starting to get this thing filled up. We're getting a little pressure in there. I'm going to go ahead and cap this one. I don't even need to throw the valve on because it's still boiling out.
So now you got two exterior ones. Are you going to keep pumping, or would you try to, at what point do you abandon that one and try to pump the different? But you've got all these units. Now that's where you maybe could pull this cork off and see if it'll pump across here.
Yep.
Okay.
I have the option since I used the cap.
Yeah. Now,
As long as I can keep pushing this uphill,
Right.
I'll probably stay right on this port
Okay.
if I can get everything to go. But by using the caps, I have the option to put a cap on this one
Right.
and go to any of those with a cap and pump from there and push it on up the hill.
Okay.
So what I'm going to do now is I'm going to go to these two ports that didn't fill from here, and I put a port in that one, and I put a port in this one. I'm going to go ahead and pull this off within about 5 minutes, so I don't want to get too far away from those. And so we'll just turn the valve off, pop that off. Okay, so there's some epoxy running out of this. That's good, but not too much. So I'm going to go ahead and put a cap on this one.
So that means there's not too much pressure on it.
Exactly, not too much pressure, but we've got a little pressure. That's good.
And one thing I wanted to mention here too is, he's saying you sit on there and you're pumping, you think it's going into your deck. I was on a bridge deck one time and we kept pumping and pumping, and I happened to walk over to the edge of the railing and we were pumping it in the river. If there's a hole through the deck, so if it's pumping for a long period of time, you might want to go underneath and make sure you're not running it in the river.
Yep.
Because that happens.
It does. And another thing that goes along with that is if you do have it coming through a crack, all the way through the bottom of the deck, if you bounce down the deck and do a different hole in a different location, sometimes that will the epoxy will set up and it will actually plug that crack, and you can come back and pump a little bit later. That's good. Before I did that, I seen a little bit coming out of this one, and I seen a little bit coming out of this one. So now I'm going to open up the door on the epoxy, and I'm going to look at my metering piston thing to see if it's actually moving slow. It may be moving slow, but my guess is it's not going to take it all. Either one of those, I don't expect it to. I'm going to double check by looking at that metering system real close. So what I would do on this one is I'm going to shut it off. I'm going to pop this off. I'm going to fill that stem up with epoxy. And then shut it off. By doing that, when I come back after that epoxy set up, we can take that ice bud and just shear it off and it'll fly out. Epoxy's about right there. Now the MEK, it'll eat these gloves right off, like right now. And don't stick your hands in the MEK without the green chemical. There's a crack running through right here, and I'm guessing the void, there's maybe two different voids, maybe a more shallow one, and they're not connected from this porthole to this porthole. So it just filled everything and wouldn't jump this crack, and it built up a little pressure. And that's why you want to kind of check them every so many minutes. So most of that's drained out. Go ahead and cap that one. I'm going to go to this one because I can see epoxy at the bottom of this one. Then probably this one, and then finally this one, and we should have it all filled after that. And then we'll go back and we'll seal the cracks. So we've got all of our ports filled up with epoxy. We've successfully filled this void. I'm on the last port, so I'm going to shut that off. Shut the coupler off. Fill the stem up with epoxy. And then once we get the delamination on board completely filled with epoxy, what we like to do is we like to go back. If there's any cracks in that delamination, we'll use this and we'll run a little bead of epoxy on top of that crack and it'll soak down in there and hopefully prevent any moisture from ever getting down in there again. So that's what I'm going to demonstrate now. We've got a small crack right here, so I'll drill that one and I'll just fill that big crack all over there. So what Clint is doing here is we've filled the void, we've sealed the cracks. Clint's sprinkling some sand, some clean braided sand on all of the epoxy, and what that's going to do is it gives it a little bit of skid resistance and also keeps you and cars from going through the epoxy. But like I say, we're going to try to wait until the epoxy is completely set up before we turn it loose to traffic. But it definitely gives us some skid resistance, which is good.
Do you sweep it up at the end too, or?
We usually, yes. Or blow it off and then sweep it up, or if traffic doesn't, blow it off by then already, you know.
Oh, gotcha.
I'll go get grind that crack out. Okay, everybody, what we're going to show you now is we've got a crack transverse in our bridge deck, and we're going to do what we call crack casing, and then we're going to seal it with epoxy resin injection. We're going to basically get a close-up of this bit. This is a crack casing blade. You can buy these any construction supply store like Rail Distributing, local contractors, Supply White Cap. But if you look at this bit, it actually has diamond and wedge shape. So what this does is we just chase that crack and grind it out. Not all the way, you don't have to go that deep. You don't go all the way to the depth of the cutters on this. It's about 3/4 of the way. What that does is it gives you a clean, fresh substrate of your concrete, and then you blow it out, get all the dust particles and everything out of it, and then you can lay a bead of epoxy in there, and it should bond very well and seal that crack. We also use these crack cases for epoxy injection on laminate or overheight bridge hits on a pre-stressed concrete beam. And we use capping gel to, after we put our ports in, we paste this capping gel, and we chase these out with these crack caser blades, then blow them out, then put our capping gel in the cracks and around the ports. We've noticed that we've had way less leaking ports by doing this crack casing. So I'll demonstrate that. This crack over here, over towards the gutter line area, we found a very deep crack and almost like a little pop out. So what you can also do with epoxy is you can do a pre-placed aggregate epoxy pack.
You don't want to put pure epoxy in.
The big volume will create a lot of heat. Funny things happen, but if you use a filler such as grated sand or washed pea gravel, even I've used actually on the bridge deck, it works pretty well. So I'll show you guys that. And the epoxy will go down through that sand. There's not an issue with that. It'll go right through it. It's just a good filler, and it keeps it from getting such a big mass volume that you start having boiling issues and what have you. Now I'm going to seal that crack that we chased, crack chased, and we load it out clean, and we're going to just seal everything up now.
The last step in the epoxy injection process, the excess epoxy, we apply the sand material on it to get a surface on it. The last thing you want to do is to once it's set up, is to sweep that off, because you don't want to leave the sand on the deck to reduce the coefficient of friction, cause any accidents, anything like that, set yourself up for liability. So it's a good idea to put the sand on there to soak it up, but sweep it off when you're done, so you don't have any reason to worry about that. That's about the last step in this process, and then they'll open it up to traffic. Once they'll check the set time from the epoxy that they put in the container and find out how long that took to set up. They'll use that to figure out when to open it to traffic, and it'll be business as usual. Feel free to call the bridge office or any one of these bridge specialists, and they'll help you out. So this is a product that I really believe can help all the local agencies maintain their bridges. And in this age, we can't be replacing bridges. We have to get into the bridge preservation mode. So this is one of the techniques I wanted to bring to the local agencies. So appreciate your time. We're here at the DOT complex in Ottumwa. I'm Eric Souhrada from the Office of Bridges and Structures. I'm here with Dewight Jones, the District 5 Bridge Specialist. We put together a video for epoxy injection last October with the assistance of Iowa State. And we had some feedback on our video. Folks thought we should probably expand a little bit more on the cleaning of the equipment, which we couldn't do out in the field. So we decided to have a supplemental video here today to go over the equipment again and to go over the cleaning of the epoxy injection equipment. And so Dwight's going to go through the trailer here step by step, show you all the equipment, and then he's going to demonstrate the cleaning process. So I'll just let you go around and go through all your equipment.
Okay, thank you, Eric. So the first item here in our trailer, we've got a 14-foot trailer with a little overhang over the gooseneck part of it. The guys can use a 12-foot, 14-foot. I think a 14-foot works pretty well. Anyway, the first piece of equipment inside of this that we have here is our CD15 epoxy pump or dispenser. It's a Lilly CD15. Pretty simple. Air comes in here, your A and your B. Then we have our material hoses that go out to a homemade little platform that we built. Next thing we just got a 55-gallon trash barrel with the liner in it just to throw all of our trash. Next thing that we have is our barrels of epoxy. Over on this side of the trailer we have our barrels of A. It's a 2-to-1 ratio, 2 parts A to 1 part B. All of our air regulators, lines and everything overhead. This is our barrels of B. When you buy a 150-gallon kit of this stuff, you're going to buy, that's what it comes in when you buy it, is a 3 55-gallon drum kit. 2 of A, 1 of B. And we carry, since we have such a large trailer, we got plenty of room, we carry an extra barrel of A and an extra barrel of B in our trailer, so that way we can just change our lids and pumps, just lift it out of one and set it down in the other, and we've always got a spare all the time. So if you get low and need to change out at the job site, we can do that. So then over here we've got a toolbox, just miscellaneous tools, hammers, sockets, wrenches. We've got a parts bin here that we carry some of our stuff, quick couplers for the injection lines, stuff like that. A few wrenches up here. And this unit right here is a generator compressor combination unit. This is a Speed Air by Dayton. It's powered by a GX390 Honda, 13 horse Honda. We run all of our air from this, and then also run our electric tools, impact hammers and stuff like that with that as well.
What size capacity would they have to have?
I don't know a minimum, Eric, but I've seen guys, other crews in the DOT, run them on a simple little air compressor that you would have in your garage. It doesn't take very much.
Like a 4-gallon tank.
Yeah, these are, I think, twin 5s, so these are just 10-pound capacity, 5 each, and it's plenty for what we do. It just constantly, when we're running it, it will generate air. So other things that we have here, we've got a broom, got an ice spud, and flat nose shovels, stuff like that. Miscellaneous buckets, ports, caps, sand for putting on your wet epoxy, give you a little skid resistance. We've got some homemade chairs, scooters that we can push around the deck and everything, keep all of our stuff in. And then miscellaneous tools and stuff up in the overhang part. When you get done at the end of the day and your epoxy is set up, and if you need to shear off your injector ports, that have epoxy inside of them, you can just take a simple flat nose shovel and just lay it on the deck and go like that, or an ice spud works very well for doing that too. Set it on the deck and just shear them off. It'll shear them right off at the driving surface, and then you can walk around and pick them up and dispose of them. So works very good, an ice spud or just a standard flat nose shovel. Other tools and accessories, shop vac, that one's got a steel housing, just lasts a little bit longer. Hoses, electrical cords, electric hammer drill. Last thing, this is called a purge tank, and this is what you use for cleaning up at the end of the day, which we're going to show you in a little bit. Clean out tank, purge tank. You can buy this straight from Lilly Corp, and we'll show you that here in just a little bit. So now what we're going to show you guys is the clean out process. And while we have you, while we're doing this, I'm just going to hook everything up like we were going to epoxy inject, and then this is what would happen at the end of the day. But I'm going to show you the hookup as well. So we keep our Tempest mixer in the MEK, and you want to keep that purge tank about half full with MEK, methyl ethyl ketone. You can get that at any paint store can get that for you. Something to be mindful of is this stuff's a pretty aggressive solvent, so you don't want to sit there and breathe all these fumes in. So just be aware of that. So when you're hooking up your Tempest mixer to your chemical hoses, you want to make sure that you always put A to A and B to B, because if you mix those up, it's going to get a chemical reaction and it's going to be very tough to get that stuff off of there. So in purposes of demonstrating the clean out process, we have to hook these all up for you, and that's a good point that Eric mentioned. Always make sure A to A, B to B every time. When you tighten these up, you just want to get these good and snug. You don't want to put too much pressure on them, but you want to get them tight enough to where they don't leak. So now we've come to the end of the day when we've got all of our ports filled up and everything. So this is going to be the clean out process. So the first thing you're going to do, you got your valve off. You're going to take the Tempest mixer right here off of your system. Then you're going to hook it up to your clean out tank. You're always going to get a little bit of drainage back feed out of your lines.
You got to make sure that that lid's sealed too.
Yeah, and if that lid doesn't seal, you can kind of move it around. Just kind of push down on it a little bit. There you can hear that the air quit hissing, so I got it sealed. The first thing you want to do is push all the epoxy out and just get air. So that's what we've just done here. Normally you're going to be outside, so you don't have to worry about, you know, the MEK. I mean, it will almost evaporate almost instantaneously, but you want to make sure the wind's not blowing in your face. So what you're going to do on this purge tank, after you get all the epoxy blown through, is you're going to shake this can. We're going to just spray it in here, and then we can, whatever we get in there, we can get rid of.
And this is why you want to have the bucket half full?
Yes, this is why you want to have your purge tank at least half full, because you're going to do this. Just a good rule of thumb, lucky number 7. I like to do 7 cycles of air and MEK and air. So I'll do that 7 times, and then I know that I've got everything's clean and I'm good. So what you're going to do is you're just going to shake this can, tip it up. You'll see the MEK come through, and then let that all run through, and then more air. Do it again. All air, a little bit of MEK, do it again. Now we're actually running out of air in our tanks, so normally we would have the air compressor running, but for video purposes we're running out of air. That's why it's not doing such a good job here, but everybody gets the idea. So do that cycle 7 times, then you should be good. At that point you can unhook your air. Pop your lid off of your tank after all your air is, you know, bled out of your tank, and I knew that mine was because mine's back fed, and you could also turn this valve and bleed it out the backside there. And also your gauge will tell you too, you know, what kind of air pressure you have. So once you get that done, you want to take your Tempest mixer off of your purge tank. We opted to make sure that this was all pointing up, so everything is forced upward, and it has to go all the way through the system to get it clean. And if it doesn't come like that, I would suggest that. Okay, then you just start cleaning up everything a little bit. So we just simply use a pipe cleaner, and we actually stick it up inside of there. After we dip it in MEK, clean that out. Something that you still want to make sure and do, clean this off with MEK before you stick it back in over here, because otherwise you're going to be mixing A and B, and that's not good. Clean it off. You can actually stick it inside of there a little bit and run it around the threads a little bit. You can also do the same thing on this contraption. And you can also run it around on your threads on that. Once you get all that cleaned off, I just take a rag and dip it in MEK, then you can wipe up any excess MEK you've got anywhere. We actually store our Tempest mixer right in our purge tank all the time. That way we know that it's good and clean. Just put it right back in there. Put the lid back on it. And you can also wipe up any epoxy off of anything with that. And also your hand tools. Yep, pretty much completes the cleanup process. Okay, so this is a handy little tool. I believe we got this from Lilly, but all this is a tool that gets your epoxy injection hose when you're actually pumping on your ports. So let's say that your line is hooked into this. This is snapped onto your ports when you're injecting. When you want to remove this and switch to another viewing port or whatever, this tool simply just slides on there, and with a little bit of pressure up, pops it off. Very handy.
Well, that concludes the video on the equipment review and the cleanup process. I just wanted Junior to expand on one other issue. We did this today in a controlled environment because he doesn't like to have the trailer freeze, and I wanted you to expand on that a little bit just to let folks know maybe they shouldn't leave their epoxy trailers outside.
Yeah, definitely. Like Eric mentioned, we're doing this in February, late February, and we would normally never be doing anything epoxy injection related with the temperatures that we have today. So we're just doing this to try to help you guys out. But that is a very good point. You never want your epoxy stuff to go through any freeze-thaw cycles. So you want to keep that in a controlled environment, at least above 50 degrees, if not more.
Okay.
I never let any of our epoxy resins go through any of those type of cycles, so we always keep those inside our heated shop on containment pallets and everything. So very important. You know, that stuff will last you a long time if you keep it in that type of environment. So we just bring our whole trailer in every single year, and it doesn't leave until we get into about April, May, when we start getting into the 60, 70 degree weather, you know, and we're well out of the cold ranges for the morning overnight temps. So yeah, our stuff doesn't go outside until basically summertime, and it comes in the fall. We always try to keep it from going through all those rain cycles.
Okay. Well, that concludes the supplemental video, and we hope this was helpful to you folks. If you need to get a hold of me, I'm at the Bridge office, 515-290-2841. And Junior's out here at the District 5 shop, and his information's in the book. So hopefully that was helpful.